What if you could cook amazing meals for your entire family without ever worrying about power outages or electric bills again? While most of us panic when the electricity goes out, the Amish have been creating incredible food for centuries using simple techniques that actually make everything taste better. Every morning before dawn, while most people are hitting the snooze button for the third time, Amish kitchens come alive with the sound of kindling crackling and cast iron doors clanging shut. The wood-burning stove isn't just a cooking appliance in these homes, it's the beating heart of the entire kitchen, the command center that turns raw ingredients into family meals without ever needing a single wire connected to the power grid. These aren't the decorative wood stoves you might see in fancy vacation cabins. These are serious workhorses built from thick cast iron that can weigh over 400 pounds when fully assembled. The metal is so heavy, it takes 3 grown men just to move one into position. But that massive weight serves a crucial purpose. All that iron absorbs heat during firing and radiates it back slowly and evenly, creating the kind of consistent cooking temperature that modern electric stoves struggle to match. The design seems almost primitive at first glance, but it's actually brilliantly engineered. The firebox sits at the bottom where split logs burn hot and clean. Above that, a large flat cooking surface provides multiple heat zones for different cooking needs. The area directly over the firebox gets scorching hot, perfect for searing meat or boiling water fast. Move a pot toward the edges, and the temperature drops to a gentle simmer that won't scorch delicate sauces. But the real magic happens inside the oven compartment. Unlike electric ovens that cycle on and off to maintain temperature, wood-fired ovens provide steady, even heat that bakers dream about. The thick iron walls absorb heat during the initial firing, then release it slowly over hours. This creates perfect conditions for bread that rises properly and develops a crispy crust that electric ovens simply cannot replicate. Temperature control requires skill that most modern cooks have never developed. There are no digital displays or automatic controls. Instead, the Amish adjust heat using a series of flue controls and dampers that direct airflow through the stove. Open the dampers wide and the fire burns hot and fast. Close them partially and the fire settles into a steady, moderate burn. It's like playing a musical instrument where each adjustment changes the entire performance. Learning to cook on a wood stove is like learning to drive a stick shift. Frustrating at first, but once you get the hang of it, you wonder how you ever managed with anything else. The fuel itself becomes part of the cooking process. Different types of wood burn at different temperatures and create different flavors. Hardwoods like oak and maple burn hot and long, perfect for all-day cooking and baking. Fruitwoods like apple and cherry burn cooler, but add subtle flavors that enhance everything from roasted chicken to baked beans. Pine and other softwoods burn fast and hot, but can leave resin flavors, so they're avoided for cooking. Split firewood needs to be seasoned properly, dried for at least 6 months to reduce moisture content. Greenwood creates more smoke than heat and can fill the kitchen with choking fumes. Well-seasoned wood burns clean and hot, producing the steady heat that good cooking requires. The Amish split and stack their cooking wood a full year before they plan to use it, ensuring perfect fuel when they need it. Starting the fire each morning becomes a ritual that connects the cook to generations of previous experience. Paper and kindling go in first, followed by progressively larger pieces of wood as the fire establishes itself. The whole process takes about 20 minutes from cold stove to cooking temperature, but experienced cooks can bank coals overnight and restart the fire in just a few minutes the next morning. These stoves serve the family year-round, providing not just cooking heat, but also warming the kitchen during cold months. The combination of cooking and heating makes them incredibly efficient, using every bit of energy the wood provides. But when summer heat makes indoor cooking unbearable, the Amish have developed another solution that keeps their homes comfortable while still providing hot meals. August in an Amish farmhouse would be unbearable if families tried to do all their cooking indoors. While the rest of us crank up the air conditioning and complain about electric bills, the Amish have solved the summer heat problem with a simple but brilliant strategy that's been working for over 2 centuries. The summer kitchen sits apart from the main house, usually connected by a covered walkway or positioned just a few steps away from the back door. This separate building might look like an afterthought to modern eyes, but it's actually one of the smartest architectural decisions in traditional farming. When outdoor temperatures climb into the 90s and humidity makes everything feel like a steam bath, the last thing any family wants is a roaring wood fire inside their living space. These outdoor cooking spaces come in all shapes and sizes, depending on family needs and available space. Some are permanent buildings with solid walls and proper roofs. Others are simple three-sided structures with basic weather protection. The most basic setups might just be a wood stove positioned under a pavilion or large shade tree. What they all share is the ability to keep cooking heat and smoke away from the main house. The design typically includes everything needed for serious cooking work. A wood-burning stove anchors the space, often smaller than the main kitchen stove, but perfectly adequate for summer cooking needs. Long preparation tables provide workspace for cutting, mixing, and assembling meals. Open shelving holds pots, pans, and cooking utensils. Some summer kitchens even include sinks with hand pumps for water, making them completely self-contained cooking environments. Ventilation becomes crucial in these spaces. Without proper airflow, summer kitchens can become smoke-filled ovens that defeat their entire purpose. The only product we'll ever promote on our channel is a book by Claude Davis, a veteran prepper, about 126 superfoods and preservation methods from crisis times like the Great Depression and wartime that are impossible to find elsewhere. We decided to promote his book because we are the last generation able to share these techniques and superfoods to our children or grandchildren. It would be a shame to see this information about highly nutritious foods and preservation methods to survive crises disappear. You can also find a book about herbal remedies from Nicole Apelian on their store. If you're watching this on TV, you can look up our channel, Frugal Solutions, on your phone or tablet and find the books by clicking the link in our channel description or any other video description. The Amish design these buildings with strategic window placement and roof vents that create natural air circulation. Hot air rises and escapes through high openings, while cooler air gets drawn in through lower windows and doors. During peak summer months, especially when big cooking projects are planned, the summer kitchen becomes the center of food preparation activity. Bread baking moves outside, taking advantage of the wood-fired oven heat without turning the main house into a furnace. Canning operations shift to the summer kitchen, where the intense heat and steam from processing vegetables and fruits won't make indoor living miserable. Summer kitchens are like having a teenager move to the basement. You still love them, but you're grateful they're making all their noise somewhere else. Large family gatherings rely heavily on summer kitchen capacity. When 20 or 30 relatives show up for Sunday dinner, the outdoor cooking space allows preparation of massive quantities of food without overwhelming the main kitchen. Multiple dishes can cook simultaneously on the larger work surfaces, and the mess stays contained in an area designed for heavy-duty cooking. The smoke management benefits extend beyond simple comfort. Wood-burning stoves produce smoke even under the best conditions, and keeping that smoke outside prevents it from settling into curtains, furniture, and clothing inside the house. Summer kitchens allow the smoke to dissipate naturally in open air instead of accumulating indoors. These buildings also serve important functions during food preservation season. Late summer brings the harvest time when gardens produce more vegetables than families can eat fresh. The intensive work of canning, drying, and preserving food generates enormous amounts of heat and steam. Summer kitchens provide the perfect environment for this crucial work without making the main house uninhabitable. Construction costs stay minimal because summer kitchens don't require the same level of finishing as main house rooms. Simple framing, basic roofing, and minimal siding create functional spaces without major expense. Many Amish families build their summer kitchens using salvaged materials and volunteer labor from the community. The seasonal nature of these buildings means they don't need heating systems or weather sealing for winter use. When cold weather arrives, cooking operations move back indoors, where the wood stove heat becomes welcome instead of oppressive. But even with summer kitchens solving the heat problem, some Amish families have found ways to make cooking more convenient year-round without abandoning their principles. Not all Amish communities approach modern conveniences with the same level of restriction. While old order groups maintain the strictest separation from modern technology, New Order Amish communities have found ways to embrace certain conveniences that improve daily life without compromising their core values. Propane cooking represents one of these carefully considered compromises. The transition from wood to propane isn't about laziness or abandoning tradition. It's about practical problem solving. Wood-fired cooking requires constant attention, regular fuel preparation, and significant time investment just to maintain basic cooking capability. A propane stove lights instantly, provides immediate heat control, and eliminates the daily routine of fire building and ash removal. These aren't the same propane stoves you'd find at a camping store. Amish propane cooking equipment is built for serious daily use by large families preparing substantial meals. The stoves feature multiple burners with individual controls, spacious ovens with reliable temperature regulation, and robust construction designed to last for decades rather than occasional weekend use. Propane tanks become the new fuel supply system, replacing the woodshed with outdoor storage areas for large propane cylinders. Most Amish families using propane keep multiple tanks on hand, ensuring they never run out of cooking fuel during meal preparation. The tanks connect to the house through underground lines or surface connections that bring gas directly to kitchen appliances. Local propane suppliers develop regular delivery routes through Amish communities, refilling tanks on scheduled visits, just like milk trucks used to serve rural areas. This creates a reliable fuel supply without requiring the Amish families to make frequent trips to town for refills. The delivery system becomes part of the community infrastructure that supports off-grid living. Temperature control represents the biggest advantage propane offers over wood-fired cooking. Turn a knob, and the heat adjusts instantly from high flame to gentle simmer. Baking becomes more predictable with oven temperatures that stay consistent instead of gradually cooling as wood burns down. Delicate cooking techniques that require precise heat management become much easier to master. The lighting process stays manual to avoid electrical ignition systems. Each burner lights with a match or the long lighter, maintaining the hands-on approach that keeps these appliances compatible with Amish principles. Pilot lights, which would burn continuously, are avoided in favor of manual lighting for each use. Switching from wood to propane is like trading in a horse and buggy for a pickup truck. You get where you're going faster, but you're still not flying in an airplane. Safety considerations require careful planning and installation. Propane gas can be dangerous if not handled properly, but the Amish approach this challenge with the same methodical care they apply to all aspects of daily life. Proper ventilation, regular equipment inspection, and community knowledge sharing ensure safe operation without professional technicians. The cost comparison between wood and propane often favors propane when all factors are considered. While the fuel itself costs more than wood from the family woodlot, the time saved in fire building, ash removal, and constant heat management can be redirected to other productive activities. For families running businesses or managing large farms, this time savings becomes economically valuable. Propane appliances also reduce indoor air quality issues that can come with wood burning. No smoke, no ash, and no risk of carbon monoxide from poor combustion makes propane cooking cleaner and healthier, especially important in tight, well-insulated homes. The maintenance requirements drop significantly compared to wood stoves. No chimney cleaning, no ash disposal, no firebox repair, and no constant fuel preparation. Propane appliances need occasional cleaning and periodic inspection, but the daily maintenance burden nearly disappears. Storage becomes simpler as well. Instead of maintaining woodsheds, splitting equipment, and covered storage areas for seasoned firewood, propane requires only secure tank storage and basic safety precautions. But regardless of the fuel source, some cooking methods remain unchanged, especially when large quantities or special occasions call for traditional approaches. When 50 relatives show up for a wedding celebration or the church community gathers for a barn raising, indoor cooking becomes completely inadequate. Even the largest kitchen stoves can't handle the massive quantities of food needed to feed that many hungry people. This is when the Amish turn to their most ancient cooking method, open fire cooking that can feed an army. These aren't the decorative fire pits you see in suburban backyards. Amish cooking fires are serious operations built for function over appearance. A typical setup starts with a fire ring dug into the ground or constructed from fieldstones large enough to burn substantial logs that create long-lasting coal beds. The key is building a fire that burns down to consistent, manageable heat rather than dramatic flames. Iron tripods become the workhorses of outdoor cooking, standing over the fire like mechanical sentries. These three-legged supports can hold enormous cast iron kettles weighing 50 pounds or more when fully loaded with food. The height adjusts by raising or lowering the kettle on chains, giving cooks precise control over cooking temperature. Closer to the coals means higher heat for boiling. Higher up provides gentler heat for simmering. Heavy-duty cooking grates rest directly over the coals for grilling meats or supporting multiple smaller pots. These grates are built from thick iron bars that can support substantial weight without warping from the intense heat. Unlike flimsy camping grates, these are permanent cooking tools designed to last for generations of community meals. The scale of outdoor cooking operations can be staggering. A single kettle might hold 20 gallons of soup, enough to serve 100 people generous portions. Multiple kettles can cook simultaneously over the same fire, each holding different dishes that complete an entire community meal. Beef stew in one kettle, vegetable soup in another, and corn chowder in a third creates variety without requiring multiple cooking stations. Wood selection becomes crucial for cooking fires. Hardwoods like oak and maple burn down to long-lasting coals that provide steady heat for hours of cooking. Softwoods burn too quickly and create inconsistent temperatures that make large-scale cooking difficult. The Amish often start their cooking fires with kindling and smaller wood, then add large logs that burn down to the perfect cooking coal bed. Cooking over an open fire is like conducting a symphony with a torch. Everything has to be perfectly timed or the whole performance goes up in smoke. Temperature control requires experience and constant attention. Unlike indoor stoves with adjustable dampers, outdoor fires depend on coal arrangement and pot positioning for heat management. Cooks rake coals under kettles to increase heat or spread them out to reduce temperature. Moving a kettle higher or lower on the tripod provides fine adjustments that can mean the difference between perfect cooking and disaster. The timing of fire building becomes critical for successful outdoor cooking. Large logs need several hours to burn down to useful cooking coals, so fire preparation often starts before dawn for midday meals. Experienced cooks can judge exactly when their fire will be ready for cooking based on wood type, weather conditions, and fire size. Weather poses unique challenges for outdoor cooking. Rain can extinguish fires or make temperature control nearly impossible. Wind can create uneven heating that burns food on one side while leaving it raw on the other. The Amish often construct simple shelters or windbreaks around their cooking fires to provide protection from the elements. Cleanup becomes a community effort when cooking operations are this large. Massive kettles require multiple people to lift and move safely. Ashes and coals need proper disposal to prevent fire hazards. The cooking area gets thoroughly cleaned and restored to prevent attracting animals or creating safety problems. The social aspect of outdoor cooking brings communities together in ways that indoor cooking cannot match. Multiple families work together, sharing responsibilities and techniques while preparing food for everyone. Children learn by watching and helping, absorbing traditional knowledge that gets passed down through generations. But while outdoor cooking handles large gatherings perfectly, the Amish have developed completely different methods for preserving meat that provide food security throughout the year. Before refrigeration existed, meat preservation meant the difference between eating well all winter and going hungry by February. The Amish perfected this ancient art form and still use it today. Not because they have to, but because smoked meat tastes better and lasts longer than anything modern food processing can produce. The smokehouse stands apart from other farm buildings, usually positioned downwind from the main house to keep smoke from drifting into living areas. These structures look deceptively simple from the outside, 4 walls, a roof, and a door, but inside, they're carefully engineered food preservation systems that can turn fresh meat into shelf-stable protein that keeps for months without any refrigeration. Temperature control in a smokehouse requires a completely different approach than cooking over open fires. The goal isn't to cook the meat quickly, but to slowly dehydrate it while infusing it with preservative compounds from wood smoke. Temperatures stay low, typically between 80 to 90 degrees Fahrenheit, far below normal cooking temperatures, but warm enough to drive moisture out of the meat. The smoking process starts with meat preparation that would make modern health inspectors nervous, but has worked safely for thousands of years. Fresh pork gets rubbed with salt and sugar mixtures, then hung in the smokehouse where it will remain for days or even weeks. The salt draws moisture out of the meat, while the smoke penetrates deep into the tissues, creating an environment where harmful bacteria cannot survive. Wood selection becomes crucial for both flavor and preservation effectiveness. Hickory produces the classic bacon flavor that most people associate with smoked meat, but it burns slowly and creates dense smoke that penetrates meat thoroughly. Applewood provides milder flavor that works well with poultry and fish. Cherry wood adds color along with subtle sweetness that complements pork beautifully. The fire management technique differs completely from regular cooking fires. Instead of hot, fast-burning flames, smokehouse fires smolder slowly, producing maximum smoke with minimal heat. Green wood or wood chips soaked in water help control the burning rate and increase smoke production. The fire needs constant attention to maintain the right balance between smoke output and temperature control. Smoking meat is like raising teenagers. It takes forever, requires constant supervision, and if you mess it up, everybody in the neighborhood will know about it. Timing becomes critical during the smoking process. Ham requires weeks of smoking to develop proper flavor and preservation, while bacon needs only days. Fish and poultry smoke much faster than red meat, often finishing in hours rather than days. Experienced meat smokers can judge doneness by appearance, texture, and even smell without ever using thermometers or timers. The hanging system inside the smokehouse maximizes capacity while ensuring even smoke exposure. Meat hangs from wooden poles or metal rods positioned at different heights to accommodate various cuts and sizes. Air circulation patterns distribute smoke evenly throughout the building, but pieces still need occasional repositioning to ensure uniform treatment. Ventilation controls at the top and bottom of the smokehouse regulate airflow and temperature. Too much ventilation, and the smoke escapes before penetrating the meat. Too little, and temperatures can climb too high, cooking the meat instead of preserving it. Adjustable vents allow fine-tuning throughout the smoking process. Weather affects smoking operations significantly. High humidity slows the drying process and can lead to spoilage if temperatures climb too high. Dry, cool weather provides ideal smoking conditions that help meat cure properly. Rain can extinguish fires or create moisture problems inside the smokehouse. The finished product keeps for months without refrigeration when properly smoked. Smoked hams hang in cool, dry places and provide protein throughout winter and spring. Bacon stores in cloth bags or wooden boxes, ready to slice and cook whenever needed. The long preservation time means families can process large quantities of meat during butchering season and eat well year-round. But meat preservation represents just one aspect of maintaining food supplies without modern conveniences. Electric mixers, food processors, and blenders have made modern kitchens sound like construction sites. The constant whirring, chopping, and grinding creates a mechanical symphony that drowns out conversation and turns cooking into an industrial process. Amish kitchens operate in peaceful silence, broken only by the rhythmic sounds of human hands working with simple, effective tools that have remained unchanged for generations. The hand crank egg beater represents the perfect example of elegant mechanical engineering. Two interlocking gear wheels multiply the force from your turning hand, spinning wire beaters fast enough to whip cream or beat eggs into perfect peaks. The motion feels natural and controlled, giving you complete awareness of texture changes that electric mixers completely mask. When cream reaches the perfect consistency, you feel it in your hands rather than guessing by sound or timer. Meat grinders attached to kitchen tables with heavy-duty clamps, transforming tough cuts into ground beef, pork, or sausage filling. The cast iron construction weighs enough to stay stable during operation, while sharp steel blades slice through meat with surprising efficiency. Different grinding plates create coarse or fine textures depending on the intended use. Fresh sausage ground at home tastes completely different from store-bought versions because you control the fat content, seasoning, and meat quality. Butter churns turn cream into fresh butter through simple mechanical action that children can master. The wooden paddle agitates cream inside a ceramic or wooden container until fat globules clump together and separate from buttermilk. The process takes 15 to 20 minutes of steady churning, but produces butter with flavor and texture that commercial products cannot match. The leftover buttermilk becomes an ingredient for pancakes, biscuits, or other baked goods. Hand crank apple peelers speed up fall processing when bushels of apples need preparation for drying, canning, or cooking. These ingenious devices hold an apple on a spike while you turn a crank that rotates the fruit against a sharp blade. A single motion peels, cores, and slices the apple into perfect spirals ready for further processing. What would take hours with a knife gets finished in minutes. Using hand tools in the kitchen is like having a conversation with your food. You actually pay attention to what's happening instead of just making noise and hoping for the best. Vegetable graters come in various sizes and configurations for different tasks. Large graters handle cabbage for sauerkraut or coleslaw. Medium graters work perfectly for cheese, carrots, or potatoes. Fine graters create zest from citrus peels or reduce hard cheeses to powder. The hand control allows you to adjust pressure and speed based on the texture you want to achieve. Rolling pins remain the gold standard for pastry work, providing even pressure and consistent thickness that no machine can replicate. The weight and balance of a good wooden rolling pin feels perfect in your hands, giving complete control over dough texture and thickness. Experienced bakers can feel through the rolling pin when dough reaches the right consistency. Manual can openers, while simple, require the right technique to work efficiently. The key is proper positioning and steady pressure rather than force. A good hand-operated can opener lasts for decades and never needs electricity or batteries. These tools require maintenance and care that connects users to their equipment. Wooden handles need occasional oiling. Metal parts require rust prevention and sharpening. This ongoing relationship between cook and tool creates familiarity that improves efficiency and results over time. The durability of hand tools means they often get passed down through generations, carrying family history along with practical function. Many Amish kitchens contain tools that belong to grandmothers and great-grandmothers, still performing perfectly after decades of daily use. But having the right tools only matters if you have proper storage for the food they help prepare. Nature solved the refrigeration problem millions of years before humans invented electricity. The Earth itself provides consistent, cool temperatures year-round if you know how to harness this natural resource. While modern families spend hundreds of dollars on electric refrigerators and freezers, the Amish dig holes in the ground and create storage systems that work better than anything available in appliance stores. Root cellars take advantage of the Earth's natural insulation properties. Once you dig below the frost line, soil temperature stays remarkably stable throughout the year. In most climates, the temperature 8 feet underground hovers between 50 to 55 degrees Fahrenheit regardless of surface weather conditions. This natural cooling system never fails, never needs repair, and costs nothing to operate after initial construction. Construction starts with excavation, usually on a hillside where natural drainage prevents water problems. The excavated space gets lined with stone, concrete blocks, or treated lumber to create stable walls that won't collapse under soil pressure. The roof typically consists of heavy timbers covered with several feet of earth for insulation. A simple door provides access while maintaining the controlled environment inside. Ventilation becomes crucial for proper root cellar operation. Without air circulation, stored vegetables develop mold and rot quickly in the humid environment. Most root cellars include 2 ventilation pipes, one near the floor for cool air intake and another near the ceiling for warm air exhaust. This creates natural air circulation that maintains proper humidity while preventing stagnation. The storage environment stays naturally humid, which benefits most vegetables but requires careful management. Root vegetables like potatoes, carrots, and turnips thrive in the moist conditions that keep them from drying out. Cabbages and winter squash store well in the moderate humidity that prevents shriveling. However, onions and garlic prefer drier conditions and often get stored in different areas or containers. Root cellars are like natural refrigerators that never break down, never need defrosting, and the only noise they make is the sound of your footsteps going down to get dinner. Storage containers and shelving systems maximize space while protecting food quality. Wooden bins hold loose vegetables like potatoes and carrots. Wire baskets allow air circulation around stored items. Wooden shelves support jars of preserved foods and containers of dried goods. The key is preventing different foods from touching each other while allowing adequate air circulation throughout the space. Temperature monitoring helps maintain optimal storage conditions. Simple thermometers show when temperatures drift outside the ideal range. During extreme weather, additional ventilation or temporary heating might be needed to maintain proper conditions. The goal is steady temperatures without dramatic fluctuations that stress stored foods. Seasonal loading patterns reflect harvest times and storage capabilities. Fall brings the heaviest usage as gardens produce massive quantities of vegetables that need winter storage. Root vegetables go in first, followed by cabbages, winter squash, and preserved foods. Spring cleaning removes any spoiled items and prepares the space for lighter summer storage needs. Different foods require specific storage techniques within the root cellar environment. Potatoes need complete darkness to prevent sprouting and green coloration. Carrots store best in damp sand that maintains moisture. Apples release ethylene gas that accelerates ripening in other fruits, so they need separate storage areas. The longevity of properly stored foods rivals or exceeds modern refrigeration. Potatoes keep for 6 months or more in ideal root cellar conditions. Carrots, beets, and turnips last through winter and into spring. Winter squash can store for nearly a year if harvested and handled properly. But while root cellars handle fresh produce excellently, preserving the peak harvest requires different techniques that capture summer abundance for year-round eating. August in an Amish kitchen sounds like a steam engine factory. Pressure canners hiss and bubble on every available burner while mason jars clink together in massive water baths that turn the kitchen into a tropical sauna. This isn't recreational cooking or weekend hobby canning. This is serious food preservation work that determines whether the family eats well all winter or struggles with monotonous meals by February. The scale of Amish canning operations would shock most modern families. Where suburban gardeners might put up a dozen jars of tomato sauce, Amish mothers routinely process hundreds of jars during peak harvest season. A single family might can 200 quarts of green beans, 150 jars of tomatoes, 100 containers of corn, and dozens of other vegetables before autumn arrives. These aren't small batches for gift giving. This is industrial-scale food preservation happening in home kitchens. Pressure canning becomes essential for processing low-acid foods safely without refrigeration. The pressure canner creates temperatures above 240 degrees Fahrenheit, hot enough to destroy dangerous bacteria that cause botulism and other food poisoning. Modern electric pressure canners make this process foolproof, but the Amish achieve the same results using heavy-duty pressure canners heated on their wood or propane stoves. The timing of canning operations follows the garden harvest schedule with military precision. Green beans get processed when they're tender but not tough. Corn must be canned within hours of picking to maintain sweetness and texture. Tomatoes need perfect ripeness, not too green, not overripe. Missing the optimal timing means inferior quality that becomes obvious during winter meals. Water bath canning handles high-acid foods like fruits, pickles, and tomatoes using simpler equipment. Large pots filled with boiling water process jars at 212 degrees Fahrenheit for specific times based on jar size and food type. This method works perfectly for jams, jellies, fruit preserves, and pickled vegetables that will brighten winter meals with summer flavors. The preparation work before actual canning begins rivals preparation for major holidays. Vegetables need washing, trimming, cutting, and blanching. Fruits require peeling, pitting, and cooking into sauces or preserves. Mason jars get sterilized in boiling water, while lids and rings get prepared for sealing. Every surface in the kitchen gets covered with cutting boards, bowls, and processing equipment. Quality control during canning makes the difference between food that keeps perfectly and jars that spoil during storage. Proper headspace in each jar allows for expansion during processing. Bubble removal prevents air pockets that can interfere with sealing. Rim cleaning ensures lids seal properly without food particles creating gaps. Canning season is like preparing for a siege. You work yourself to exhaustion for weeks, but when winter storms hit, you're sitting pretty with a pantry full of summer. The sound of properly sealed jars creates music that experienced canners recognize immediately. The distinctive pop of lid sealing tells you the vacuum has formed correctly, and the food will keep indefinitely. Jars that don't seal get reprocessed immediately or moved to immediate consumption rather than long-term storage. Storage systems for hundreds of jars require organization that would impress professional warehouse managers. Basement shelves hold rows of identical jars labeled with contents and dates. Rotation systems ensure older jars get used first while newer ones wait their turn. Inventory tracking prevents running out of favorites while avoiding waste from forgotten jars. The variety of foods preserved through canning extends far beyond simple vegetables. Soups, stews, and complete meals get canned for quick winter dinners. Meat dishes like beef stew or chicken and dumplings provide protein without requiring fresh cooking. Even complete meals like chili or vegetable soup can be opened and heated for family dinners. The investment in canning equipment pays for itself quickly when compared to buying equivalent amounts of commercial canned goods. A pressure canner, water bath canner, and several dozen mason jars cost less than most families spend on groceries in a month, but the equipment lasts for decades of food preservation. But even with extensive canning operations providing shelf-stable foods, some storage methods require different approaches that work without any heat processing at all. Winter becomes harvest season for something most modern people never consider gathering: ice. While suburbanites curse frozen ponds and scrape ice off their windshields, the Amish see winter as an opportunity to collect tons of free refrigeration that will keep their food cold all summer long. The ice harvesting process starts when pond ice reaches at least 6 inches thick, strong enough to support workers and equipment safely. Teams of men work together using specialized ice saws to cut uniform blocks typically measuring 22 by 11 inches. These aren't random chunks of ice. Each block gets cut to precise dimensions that stack efficiently and fit perfectly into the storage systems that will hold them through summer heat. Ice houses provide the storage solution that makes year-round refrigeration possible without electricity. These buildings use double-wall construction with thick insulation between inner and outer walls. Sawdust becomes the insulation material of choice because it's cheap, readily available from local sawmills, and provides excellent thermal protection when packed tightly around ice blocks. The loading process requires careful planning and physical strength. Ice blocks weighing 40 to 50 pounds each get hauled from frozen ponds to ice houses using sleds or wagons. Workers stack the blocks in precise patterns that eliminate air gaps while allowing sawdust to fill every space between blocks. Proper stacking techniques can preserve ice for 6 months or longer, even through hot summer weather. Storage efficiency depends on maintaining the right balance between ice density and insulation coverage. Too little sawdust allows heat penetration that melts ice quickly. Too much sawdust wastes space and reduces storage capacity. Experienced ice harvesters know exactly how much sawdust to use for maximum preservation with minimum waste. The icebox becomes the home refrigeration system that uses harvested ice for daily food storage. These insulated wooden cabinets feature compartments for ice blocks at the top and food storage areas below. Cold air naturally sinks from the ice compartment, creating refrigeration temperatures throughout the food storage areas. Drain systems remove meltwater without creating mess or odors. Using an icebox is like having a refrigerator that runs on winter. It's free, it's quiet, and the only maintenance required is remembering to add more ice when the old stuff melts. Temperature management in ice boxes requires understanding how cold air circulation works. Food placement affects cooling efficiency, with items needing the coldest temperatures positioned closest to the ice compartment. Dairy products, meat, and other perishables go on the top shelves where temperatures stay lowest. Vegetables and less sensitive items can be stored lower, where temperatures are more moderate. Ice delivery becomes a regular routine during summer months when melting reduces the ice supply in home ice boxes. Fresh blocks get retrieved from the ice house and transported to kitchen ice boxes as needed. The frequency depends on outside temperature, icebox efficiency, and family food storage needs. The ice house also serves community needs beyond individual families. Multiple families often share ice harvesting work and storage facilities, spreading the labor burden while ensuring everyone has access to refrigeration. Community ice houses can store enough ice to supply several families throughout the summer. Quality control during harvesting affects how long ice will keep in storage. Clear, solid ice lasts much longer than cloudy ice filled with air bubbles. Harvesting sites get selected for clean water that produces the best quality ice. Timing the harvest for optimal ice thickness and clarity makes the difference between ice that lasts all summer and ice that melts by early spring. But even with ice providing excellent refrigeration, the cookware used with all these preservation and cooking methods requires special characteristics that modern kitchen equipment often lacks. Cast iron cookware represents the ultimate marriage between functionality and durability in the kitchen. While modern cooks chase after the latest non-stick coatings and lightweight materials, the Amish stick with cookware that their great-grandmothers used and that their great-grandchildren will inherit. A properly maintained cast iron skillet doesn't just last for decades, it actually improves with age and use. The secret lies in the seasoning process, which has nothing to do with salt and pepper. Seasoning refers to the polymerized oil coating that builds up on cast iron surfaces through repeated heating and oiling. This natural coating creates a non-stick surface that rivals any chemical coating while adding iron to the food and improving with every use. The more you cook with cast iron, the better it performs. Heat retention sets cast iron apart from every other cookware material. The thick iron walls absorb heat slowly but hold it steadily, creating even cooking temperatures that prevent hot spots and burning. Once heated properly, a cast iron pan maintains consistent temperature even when food gets added, unlike thin aluminum pans that lose heat quickly and create uneven cooking. Versatility makes cast iron the Swiss Army knife of cookware. The same skillet that fries bacon in the morning can bake cornbread in the oven at night. Cast iron Dutch ovens work equally well for stovetop stews, oven roasts, or outdoor cooking over open fires. No other cookware material adapts to so many different cooking methods and heat sources. The weight of cast iron provides advantages that lighter cookware cannot match. Heavy pans stay put on stovetops without sliding around during cooking. The thermal mass helps maintain steady temperatures and prevents temperature swings that can ruin delicate dishes. Even heat distribution eliminates the hot spots that plague thin, lightweight pans. Maintenance requirements for cast iron seem intimidating to modern cooks, but the Amish approach it as simple routine care. After cooking, the pan gets cleaned with hot water and a stiff brush while still warm. Soap isn't necessary and can actually damage the seasoning. A light coating of oil applied while the pan is still warm maintains the protective seasoning layer. Cast iron is like a good marriage. It takes some work to maintain, but if you treat it right, it just gets better with age. The economics of cast iron cooking favor long-term thinking over immediate convenience. A quality cast iron skillet costs less than a fancy non-stick pan, but lasts for generations instead of years. The durability means never replacing cookware due to scratched coatings or warped bottoms that plague modern lightweight pans. Cooking performance in cast iron surpasses modern alternatives for many applications. Searing meat creates better crusts because the heavy metal holds heat better. Baking in cast iron produces crustier breads and more evenly cooked casseroles. Frying achieves more consistent results because temperature stays steady throughout the cooking process. Size options accommodate everything from individual portions to family-sized meals. Small skillets, perfect single servings, or side dishes. Large pans handle entire family meals. Massive Dutch ovens can feed crowds during community gatherings. The variety means having the right size for any cooking task. Outdoor cooking capabilities make cast iron essential for open fire cooking. The heavy construction withstands direct flame contact that would destroy other cookware. Temperature control becomes easier because the thermal mass moderates heat fluctuations from inconsistent fires. The health benefits of cast iron cooking include natural iron supplementation, especially important for people with iron deficiency. Acidic foods cooked in cast iron absorb measurable amounts of iron, providing nutritional benefits that other cookware cannot offer. These Amish methods prove that the best cooking doesn't need electricity or gas, just simple techniques that create incredible flavors. Start with one or two of these methods, and you'll discover food that tastes better than anything modern appliances can produce.